Good morning, dear students. Myself, Dr. Priya, working as Associate Professor in Chemistry, Department of Humanities and Sciences, MLR Institute of Technology, Hyderabad. In today's session, we are going to study about zinc-air batteries. Zinc-air batteries construction and working principle that is involved in the zinc-air batteries. So, let us start with the construction part. So, coming to the introduction of zinc-air battery, these are also known as modern batteries. Zinc-air batteries are also known as modern batteries, and these are the examples for primary batteries. That means the cell reactions are not reversible. That means if you store the chemical energy, whenever it is used as a source of electrical energy, it is able to convert that stored chemical energy into electrical energy. So, that's why these are examples for primary batteries. So, we will call them as modern batteries also. So in this, what will happen is, and coming to the construction part, zinc, it is able to involve in oxidation easily by absorbing atmospheric oxygen. The zinc is able to involve in oxidation with the help of oxygen that is absorbed from the atmosphere. So for this to happen, so it will have, what are the three major components that were present in a battery construction? One is anode, other one is cathode, and the third one is electrolyte. So coming to anode, we are making use of granulated zinc particles, that means the zinc granules, which were made in the form of a paste or slurry, with the help of electrolyte. So in this zinc-air battery, we are going to make use of KOH, potassium hydroxide, as electrolyte. So in anode and cathode, we are going to consider porous carbon electrodes. In anode chamber, that porous carbon electrode, it is coated with zinc particles which were made in the form of a paste using electrolyte, that is KOH. So this will play the role of anode, that means negative electrode. As I told you, porous carbon electrodes were considered in place of anode and cathode. Into the cathode carbon electrode, we are going to allow the passage of oxygen, that is atmospheric oxygen. It is absorbed by the cathode electrode. As it is porous carbon electrode, it will have a nature to absorb atmospheric oxygen, right? So this atmospheric oxygen, as and when absorbed into the cathode chamber, it is able to combine with the electrolyte water molecules. As a result, it is able to release OH minus ions. As oxygen, it is absorbed in the cathode chamber, immediately it is able to release OH minus ions. These OH minus ions are able to combine with the zinc metal ions, thereby convert into corresponding zincate ions. So zincate ions formation will take place. This zincate ions further involve in decomposition, thereby converting into ZnO, that is zinc oxide and water. So what will happen? We have to consider granulated zinc particles paste weighed with KOH will act like anode, that is negative electrode, and atmospheric oxygen, it is absorbed in the cathode chamber. It is able to form OH minus ions. These OH minus ions combine with zinc. As a result, zincate ions will be formed, and these zincate ions again decompose to form ZnO and water. That means flow of electrons will take place from anode to cathode, that is current will be produced. Water and hydroxyl ions are recycled so that the water will not be consumed. Continuously that absorption of oxygen will take place, then only OH minus ions will be released. That means atmospheric oxygen is available so that it is able to release OH minus ions. Until and unless entire zinc heat is not consumed, this battery will work. If once the zinc heat is exhausted, this battery working will be stopped. So that is what is going to happen. That's why it is an example for primary battery. So if you use this one as a source of electrical energy, it is able to release an output voltage in the range of 1.35 to 1.46. But theoretically, it is able to release 1.6 volts of output voltage. But practically, it is able to generate output voltage in the range of 1.35 to 1.4 volts. So let us see the representation, cell representation. As I told you, granulated zinc particles we are going to consider in the place of anode. So while representing a cell, we have to write the metal electrode first and then followed by electrolyte, that is KOH in this case, whose concentration it is 6 molar, and then followed by cathode, that is cathode electrode. So this is porous carbon electrode into which atmospheric air it is, or atmospheric oxygen it is absorbed. So this is acting like anode electrode, that's why negative sign it is represented. This is acting like cathode, that's why positive sign it is represented. So let us see the construction of zinc air battery. So as I told you, two porous carbon electrodes were placed in anode and cathode chamber, and into this cathode chamber, granulated zinc, which is made in the form of a paste with the help of KOH, is applied as a deposition on the anode electrode. So it will play the role of anode electrode, which is having a negative charge. And then in cathode electrode, we have placed a porous carbon electrode. So this is able to absorb atmospheric oxygen from the atmosphere or the air. It is able to absorb oxygen as and when it is absorbed. Here we are using catalyst, bifunctional catalyst also we are going to make use. It is like a carbon nanotube which is having a doping of FeNC or cobalt oxide. Cobalt oxide carbon nanotubes will play the role of catalyst. So this is nothing but a bifunctional catalyst. Here we are using basic medium, right? This bifunctional catalyst, what it will do is, it is whenever it is able to sense difference in the pressure of oxygen inside and outside and inside, which is penetrated or absorbed. If it is able to notice that pressure difference of oxygen inside and outside, then it is able to make this oxygen to actively participate in reactions. So as a result, this oxygen is able to release OH minus ions into the solution. Then what will happen? These OH minus ions will travel from this cathode chamber to anode chamber via this membrane, or we can call it a separator. There we are having Zn plus ions, zinc metal ions, Zn2 plus ions. So they combine with OH minus ions, and as a result zincate ions will be produced. These zincate ions again involve in decomposition, thereby able to release zinc oxide. Along with that OH minus ions will be again regenerated. So till this atmospheric oxygen availability is there, it is able to release OH minus ions, and till this zinc metal is there, that means if it is not exhausted, this is able to generate electrical energy. So if you notice the reactions, as I told you, in anode reaction what will happen, this zinc is able to lose 2 electrons, thereby converting into Zn plus 2. So and then what will happen, this oxygen, if you notice the previous case, here the reactions are there clearly mentioned. So in this, oxygen is able to accept those electrons that is involving in reduction. So this is example for oxidation, and this is example for reduction. Is able to accept the electrons that were lost by the zinc metal, and it is able to generate OH minus ions. So these OH minus ions will travel from cathode to anode. In cathode chamber we have Zn plus 2 ions, Zn plus 2 ions. So thereby these two get combined to form zincate ions. These zincate ions will involve in decomposition again. As a result, Zn will be produced, along with that OH ions will be generated. So this is about zinc air battery. And then applications means these zinc air batteries are having applications in so many like hearing aids, and then small cameras, and then in electrical vehicles also it is having lot of applications. So in today's session we discussed about zinc air battery. It is an example for primary battery. So in that we have studied its construction, and then working, what are the cell reactions that were involved, and after that applications, of zinc air battery. So in the coming session or in the next session, we are going to study about lithium ion battery, which is an example for secondary battery. Likewise, what we have studied for zinc air battery, construction, working and applications, likewise we have to discuss about or learn about lithium ion battery. So that's all for today's class. Thank you so much.